Hello everybody. So Imaduddin is my master's student at the last minute U-turn. He decided not to present, so that's me here. Our work is on geo-environmental solution of plastic solid waste using stabilization process. So we basically use some plastic to stabilize the soil. Table of contents is introduction, what's the problem of solid waste in Cyprus, using plastic waste as soil stabilizer and soil properties in Cyprus, materials and methods, and conclusions. So, what is solid waste? It is a term used for any discarded or abandoned material. It could be domestic, industrial, commercial, or agricultural, or biomedical. The texture of solid waste may be liquid, solid, or semi-solid, even gas. One of the main components of solid waste, as we know, is synthetic polymers, and the first production of synthetic polymers at industrial scale was started in the early 1940s. Major source of solid waste is residential, industrial, commercial, institutional, agriculture, and biomedical. Example of this: waste tires, septage, household garbage, appliances and vehicles, construction and demolition debris. And it's not only that it doesn't look clean or it smells. The main problem of that is the impact of it on the climate change by the methane gas that it emits from the landfills, and also the greenhouse gases that affects the greenhouse effect, and it increases the temperature of the earth. So the consequences: emission of polluting gases brought about by the burning of garbage containing plastics, which causes air pollution. This plastic goes to sea, it affects the living organisms, it blocks the drainage, it litters. In Cyprus especially, that's very important because here is a touristic area, and in many areas we can see the littering. Plastic bags, just whenever it's windy, they're flying around. The general method of disposal, which is landfills, causes bad smell and emissions of methane gas, which is explosive and contributes to greenhouse gases. And the traditional incineration of waste also causes problem by making the air pollution. So, by a study in Cyprus, which is made in 2011, these are the percentage of different types of wastes in Cyprus. The organic waste is the 41% of it, and it's followed by the papers and then plastics, which are 15%, which is quite a huge amount. So, soil stabilization. I am geotechnician, so my work is with soil stabilization. Soil stabilization is that some soils are not good enough, their engineering properties are not good enough for the construction. So we add some other material to it to make it stabilized. So the properties will be improved, so we can make roads or houses or buildings on it. So basically, the traditional method is adding cement, lime, fly ash, those things that they are made actually. So this is not very feasible by money, and it's not good for the environment anyway, because again we are going to consume some new resources. So why soil needs stabilization? Some subsoils are not suitable for construction, for example, expansive clays. Stabilization increases their shear strength, the shrink soil properties of the soil, and improves the load-bearing capacity. So this shrink soil that we're talking about, some of the soils, clay soils, expansive soils that we're talking about, in the wet season, they absorb the water and they increase their volume. And in summer, they will shrink because of this dryness and heat. So if we have some light buildings on it, light construction on it, this construction will be affected by that. For example, these cracks that you see in pavements, many of them in Cyprus, is because of these expansive clays. In Cyprus, Mainly it is alluvial soil, swelling clays, and collapsible soils. So basically Kyrenia, Lefkosia, up to Güzelyurt, many parts of Massaria, they are all expansive clays. And only some little areas in Troodos and the west of the island are not actually sedimentary. The rest is sedimentary and expansive and soft clays. So the scope and objective of this stabilization is to improve the engineering properties of the soil, such as shear strength and bearing capacity, to provide the alternative solutions for disposal of the plastic waste, decreasing cost of soil stabilization by using cheaper material, converting the waste materials and environmental hazardous material into useful material. Advantage of plastic in road construction. So using plastic in soil is not such a common method, though it was before used in asphalt material. So in asphalt material it was found that it lessened the bituminous use to 15%, and also it made it more durable up to 10 years, because normal roads is like it was 4 to 5 years, it increased to 10 years. So we thought maybe you can use it in soil. To perform the experiment, soil was collected from the campus here at the back of the hospital and nearest university. And the plastic shopping bags, they was collected from the university students, so the extra bags, plastic bags they had at home. So plastic strips are different percentages were added and mixed with soil. First we had one 0% batch that didn't have any stabilizer to see how the soil properties is without stabilizer, and then 0.2%, 0.3%, 0.4%. They were mixed with soil, and the tests were performed were Atterberg limits, compaction factor test, unconfined compression test, and CBR, Californian bearing ratio. These are the Atterberg limits. So the liquid limit is 48%. So 50 is the limit for highly liquid, highly expansive, let's say. And the plasticity index is 17, so it means that it is almost at the limit of being acceptable, but it could need some stabilizer. So here you can see in the photograph, the left one are the strips of the plastic. It was almost 4 to 1 centimeter cuts, and it was mixed with soil. And they were, for finding the water content, they were put in the oven at 100 degrees, and we found that this degree doesn't burn the plastic. So this is the compaction results. To find the maximum dry density of the soil, the best compaction that we have. So this green one, the light green one, is with 0 plastic. Addition of plastic with 0.2 and 0.3 actually decreased the maximum dry density, but 0.2 and 0.4. But 0.3 with yellow line had almost the same, even better maximum dry density. So actually it is improved. So for the unconfined compression test and bearing ratio, we compacted the soil at its best maximum dry density with the plastic at the left, and then we did the tests also for unconfined compression. We used the laboratory of Chamber of Civil Engineer to find the results. These are the unconfined compression test results. As you see, the lowest curve is for the soil that doesn't have any stabilizer. So with addition of plastic, we can see that the strength is increased up to 145%. So we can see that with 0.3 and 0.4%, we have the best results. And also CBR test, bearing ratio. We can see that addition of plastic increased the bearing ratio from 1.59 kilonewton to 2.4 kilonewton. So the conclusion is that after mixing plastic strips with soil, the behavior of soil was improved. Better bearing strength and shearing capacity was achieved by addition of plastic content. The optimum at 0.3%, it was with the maximum dry density of 1.62 gram per centimeter cube. And well, we have the water content here, but theoretically adding plastic shouldn't do anything to the water content because it doesn't go to the reaction. Both in unconfined compression and Califarian bearing ratio, the maximum strength was achieved at 0.4%, but we are losing the maximum dry density from 0.3 to 0.4. So it is concluded that at 0.3% plastic content, the soil has better packing with good unconfined compression strength and CBR values. So this method could contribute to solving the Cyprus plastic waste problem by recovering and reusing the major fraction of plastic bags in road and pavement construction. So that's a new work. Actually, first it started with my capstone projects undergraduate students. Then my master's student continued working on the research analyzing the result. So if it is worked with different percentages or probably different sizes of these fibers, probably we could get some good results by finding the most efficient content of plastic to be used for the subgrade of pavements and the roads. And I think most of you have heard this. When the last tree has been cut down, the last fish caught, the last river poisoned, only then will we realize that one cannot eat money, as said by a Native American. And this picture that you see, it's a quarry that it is very common in Cyprus. So they bite the mountain. Thank you for your attention.
Thank you so much for your presentation. Please, if we have some questions from yes.
I think you are going to continue this research.
Yeah.
Maybe I would suggest to include in your research the effect of sizing the plastics, shredding it in different sizes so that mixing with soil would be somewhat different and improved. And with that improvement in the amounts of the magnitude of the plastic material into the soil will increase to higher levels, like 1% or so, or will it also influence the parameters that you have measured so far?
Yes, if I can put my student to do that, I will.
Over there?
Yeah, it's over there. Imad, wake up. This is the student doing this.
Yes, we have one question from here again.
Sure.
Process is used for this proposal to be done to mix plastic with soil.
Which kind of, sorry?
Which kind of process?
So the mixture was quite easy. I mean, the percent just was found by weight of it. So though it's like 0.3 sounds very small, but because it's plastic and doesn't weigh much, so you saw that the amount is not very small. So it's just mixed by hand easily. So if you want to do it in road, I mean, they add the cement and lime, the same thing. So when they put the layer, then they add the cement. So they can put the layer and add the plastic.
Talking maybe about the dispersion of the inside the mix.
Well, the dispersion was just addition of both of them and mixing without any special care. So because if you want to do it in road, we cannot, put them one by one. That wouldn't be feasible.
And the two previous slides, could you?
Sure. Here?
Just one before.
Yeah.
Yes, here, this graphic. What are the axes meaning? And
Oh, yeah, the unit. Sure. The y-axis is actually the unconfined compression stress in kilopascal. Unconfined compression stress in kilopascal. And the y-axis is the strain in millimeter. Yeah. That's a huge mistake. Sorry for that.
thank you.
What about
My question is about temperature.
Yeah.
Cyprus is a lot of heat, so you go to the mountain road and with the trucks carrying the stones,
Yeah.
you see the asphalt all melted. So So
asphalt is
how
not.
about plastic? Did you put plastic?
So we tried that in the oven to up to 110. We weighed that before putting the oven. We left it in the oven for 2 days, 110 degrees, and took out. The weight was not changed. So we understood that, okay, it's not burned, so we can use it, because we know that the asphalt that is going there, you know better than me, up to 70 degrees, in summer sometimes more. So
You
we,
cannot burn plastic and now it's something.
Yeah.
used.
so it just stays there forever.
If you could, that would be excellent.
Yeah, we wish.
I want to ask, what is the possibility or the potential of leaching of some of the not good material plastic into the groundwater?
Yeah, well, actually, plastic, well, I'm sure that in front of you as a geotechnician, I'm not the expert to talk about that, but it doesn't, it's not worse than going to landfill, because it doesn't go to reaction with things that are under the road. There is no acidic or basic thing to dissolve that actually, so it wouldn't affect.
But it will decay because it won't stay there forever. And if it decays, it might leach some of the, speak kind of only, talking of plastics and how.
So
they can leach
that
out.
should be actually researched more by, expertise in this thing, because all I know is that this they go to microplastic, but they don't leach to the water. So if we put it in the,
You may probably look into this if this is going on.
well, that could be probably tested by giving the same sample, putting in the water, and probably heat it and cool it to speed up the process, and give water from the top and collect water from the bottom of it for like a year or something, and then collect.
Midem kezdetben az
Yeah, Derin hocam.
Dr. Bilal asked
Sir, sure.
It's not leaching, but it's turning into microplastic at the same time. So would that mean that the performance of this sterilization will be changing? How long will it take?
Well, that's changing, that decaying will not pass the life of the road itself, because it's long enough. So, yeah, by the time that it starts to decay, the asphalt is already gone, the road is already changed. Yeah.
yes, Paul.
I would, as member of this university, I'm very happy to say that the group in our faculty should be praised for the ingenuity of the work that was presented. Before that was Pınar'ın and now Mission. And there is one gap that we didn't evaluate in this study. Where is the artificial intelligence in that subject?
We will get to that.
You should include some artificial something.
Okay. We will. Hopefully we will. I'm thinking of that. Sorry. Okay, thank you.